Okay. So atoms and molecules, chemistry mein, this is the most important chapter that you will be studying. So this forms like your basics of chemistry if you are planning to continue chemistry later on. 10th May, you're going to have like all the chapters are going to deal with reactions, like different types of reactions, like acids reactions, metal reactions, non-metal reactions, that sort of thing. And like the basics from this chapter will help you in 10th grade also, like knowing the valency helps, knowing how to figure out the formula, like if you have sodium and chlorine, un dono ke beech mein what compound will be formed. Or if you have, let's say, calcium and sulfate ion, they'll form calcium sulfate. So calcium sulfate ka formula kya hoga, what it is made up of. So knowing all of that will help you so much with grade 10 chemistry syllabus, makes it so much easier that way. You don't have to deal with like trying to memorize or remember all the formulas and things like that. So the basics of it, that knowing ki formula kaise banta hai, or if you have like a formula like Mg CO3, then what does it mean, like uska naam kya hai, like how does it split, Mg ka valency kya hoga, carbonate ka valency kya hoga. All of that stuff you are going to learn in this chapter, atoms and molecules. So having that basic understanding of what are things made up of is what you're going to learn in this chapter. And not just 10th, if you're planning to take chemistry going forward, the basics, like this chapter, you need to be really, really strong with. Like 11th, 12th May, you'll deal with mole concept. What does one mole mean? How do atoms like bond with each other? As you said, covalent bond, ionic bond, all of that stuff, uska basics are in this chapter. If you're strong in this chapter right now, it'll help you in your 10th, it'll help you in your 11th, it'll help you in your 12th. Like you don't have to learn all of it again. You won't be lost when you come across that. Okay. So first and second chapter, you learned about matter. Yeah, Swayam, what's up?
Mom, are you like gonna give some notes of it today? Like any writing stuff?
Yeah, of course.
Okay.
Like any chapter, you will be, yeah. This is default. Like any chapter that we do, even if it's revision, you have to solve questions. Always need to write. So whenever you come to class, have a book and pen with you. Okay. So first,
I have it.
Okay.
I have it ready.
First two chapters we talked about matter, right? So your matter in your surroundings was mainly, okay, if I take a bottle, what sort of particles will I find? Like how are they arranged? Like can I melt it? Like what happens if I apply pressure to it? Is it compressible? Like you learned about matter in a way where, okay, like what happens when I affect it physically in terms of temperature, in terms of pressure, that sort of a thing. Like solids melt into liquids, and melting process mein kya ho raha hai? Like the atoms are moving faster and faster that way. Second chapter dealt with again the physical interaction. So if they're just mixed together, if there's no reaction happening, then you get mixtures, and depending on what two things you mix together, you get either solutions or colloids or suspensions. And then there were techniques of how are you, like if you want to separate mixtures, something that's not like chemically combined, what do you do with it? Now this particular chapter, we are going to deal with the chemical part of it. Okay, so if I have a glass bottle, fine, it's a solid, and if I compress it, if I heat it, okay, it's going to affect it in this way. But what is the bottle actually made up of? Like if I zoom into it, it's made up of particles, yes, but what are those particles? Are they atoms? Are they molecules? If I add water in it, will there be any reaction? If I add acid in it, will there be reaction? Things like that, how, like, okay, I have two bottles, both of them are transparent, but how is the particles that make up this one different from the particles that make up this one? So you're going right down into the nature of substances, the chemical nature of substances. So this chapter is going to deal with all about atoms and molecules. Okay. All right. So to start off, some of the words, like a lot of the terms in this chapter, you may have already learned about. So let's like have a quick refresher about them. So the first term is atom. So what do you understand by the word atom?
Like the fundamental unit of life.
Of life.
Oh, sorry. Sorry, of the object.
I mean, technically, sure, but actually, yeah, not of life. But yeah, fundamental unit of what?
Can you repeat?
Fundamental unit of what?
Of any substance.
Any substance? Yes, absolutely. So atom is a smallest particle of an element that cannot exist independently and retain all its chemical properties. Okay. So yeah, technically, yeah, absolutely. So if you break something down to the smallest particle, while still keeping the nature of that particle, like for example, if I take an iron block of metal, then if I break that metal down, I get two pieces of metal. Then I keep breaking it down, like breaking it down. So the smallest particle that I get by breaking something down, while also keeping its nature as the metal substance, as this being iron. So that smallest substance is an atom. So if you break an atom down, it won't have the properties of iron anymore. It turns into a completely different thing. Like it'll have different properties. So the smallest substance that can exist independently while still retaining all its chemical properties. So that's an atom. How does it differ from a molecule? Like what's the difference between, yeah.
When two atoms join together, it's known as a molecule.
Two atoms join together. So if I keep two atoms just side by side in like a small enough box, will I get a molecule?
No, ma'am, they should join. They should join.
How?
Ma'am,
Join chemically?
Yeah.
Correct. That's a keyword. So when they are chemically bonded together or chemically combined. So then when there is a bond between them, then you get a molecule. Okay. So molecule is the smallest particle of an element or a compound capable of independent existence. So all atoms cannot exist independently. The reason for that we'll get to see when we study about atoms. But molecules can exist independently. So they're capable of independent existence under ordinary conditions. So it shows all the properties of the substance. Okay. So molecules are formed when atoms are chemically combined with each other or when they form a chemical bond between them. Okay. Note down these definitions, okay? Like write about atoms, write what is a molecule, note it down.
Actually, I'm writing on point as it, okay?
Yeah, perfectly fine. Like the key thing is you need to understand and you need to remember it. Whatever helps you revise in later revisions, note it down. You can write down whatever is highlighted here also. So atom, you can write smallest particle that cannot exist independently and retain chemical properties. These 2 points should be there. Molecules, smallest particle of element or compound capable of independent existence, shows all properties of the substance. And then you can add an additional point that molecules are formed when atoms are chemically combined with each other. So you can write either chemically combined or you can use the word bonded, chemically bonded to each other. Okay. Let me know when you've noted it down, and we'll go to the next part.
Yes, ma'am.
Done. Okay. Sujal is also done.
I'm writing.
Yeah. Let me know when you're done, and then we'll resume. Okay. Suhani and Ashka are also done.
Ma'am,
Ma'am.
I'm confused. Ma'am, for an atom, can it retain all its chemical properties, or it cannot retain its chemical properties?
It can retain all its chemical properties.
Okay, ma'am.
Yeah. That's what makes it like an atom of the substance. Jab tak atom hai, that thing is still ion, but when you break down the atom, then it's not ion anymore. That way.
Ma'am, I'm done.
All right. The next thing we'll talk about is ion. Have you guys heard of this word before, ion?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
No. Okay. So what do you mean by an ion?
Ma'am, like when a compound is charged either positively or negatively is called an ion.
Kind of, not necessarily a compound. So basically, any atom that has a charge, like you have an atom, it's neutral, like it's not positive or negative. But if that atom becomes charged, if that atom gets like a positive charge, or a negative charge, then we call it an ion. Neutral hai to atom hai, koi bhi charge hai, so it becomes an ion. Okay, so ions are important because a lot of compounds, like compounds matlab they're made up of molecules that are chemically combined with each other, right? So a lot of these atoms are not like neutral. So if you take salt for example, salt का chemical composition क्या है? Table salt का जो खाते हैं.
NaCl.
Correct. NaCl, na? And do you know what this Na and Cl stand for?
Sodium chloride.
Very nice. So Na is symbol for sodium and Cl is the symbol for chloride, because that's what we'll get to. So Cl is actually a symbol for this element called chlorine. But when they combine to form table salt, they don't exist as regular sodium atom and chlorine atom. So first, Na gets a positive charge, turns into sodium ion. Cl gets a negative charge, turns into chloride ion. And then the positive and negative opposite charges attract each other. So that's how you get NaCl, the compound. Okay. So compounds that are composed of usually अगर एक metal और एक non-metal से बना हुआ है, if that particular compound is made of a metal and a non-metal, then they don't exist as regular atoms. They turn into ions and then they are able to combine with each other. Okay. So turning into ions matlab they get charges, like this particular sodium chloride mein jo hai, that this is technically made up of Na plus and Cl minus. And because, so these charged particles are called ions. So this is a sodium ion, this is a chloride ion. And because these ions have opposite charges, they attract each other and they form a compound. Clear?
Yes, ma'am.
Okay. All right. Ions. Uske baad you have anion and a cation. Okay. So I just told you, right? Like it's made up of oppositely charged ions. So agar wo positively charged ions hai, ion is a charged species. If that charge is a positive charge, then it's called cation. And if the charge is a negative charge, then it's called an anion. This is pretty important, just to not get you confused. Cation, cats have pos, so positively charged ion is a cation. So that leaves anion. Anion may you have the letter N, so that's negatively charged. These are just names, just to differentiate. अगर पॉजिटिव चार्ज है तो कैटायन बोलते हैं, अगर नेगेटिव चार्ज है तो उसको एनायन बोलते हैं. That's it. Okay. So note down definition of, or the meaning of ion, anion, and cation.
Ma'am, done.
Huh? All right. Suhani, Swayam are done.
Yes, ma'am.
Samriddhi is also done. Cool. So you can just note down ion is basically charged species are ion, or if you want to elaborate, you can say when atoms become charged, then they're called ions. And then anion negatively charged ion, cation is positively charged. That's it. All right. Okay, then the last one is valency. Now, what do you mean by valency?
Mom is the combining power.
Combining power, you can, it's
Ma'am, valence electron is the electron which is in the last shell. Extra electron in the last shell.
Nice. Okay, you're familiar with valence electrons and all. Yeah, that'll help. So combining power matlab when an atom forms a compound, right? So it's like how much can it, to what extent can it combine? So if it is able to form, can it share one electron or two electrons or three electrons? Or in other words, can it?
Mom, it should replace or combine with other elements, atoms.
Correct. Like by how much can it combine with other elements? So that is called valency. So valency, we'll come back to it. We'll study it more in detail. So just like summing up the definition, it's just combining power of an element. When we elaborate, you'll have a better idea of it. Okay. All right. Now coming to the whole like actual chapter. All right. So laws of chemical combination. Okay. So this chapter, we're going to deal with the chemical properties, or where do the chemical properties of elements come from? And chemical properties, matlab, how do they behave with other chemicals? That's all it means. How do they behave with other chemicals in the sense? What sort of reaction, like first, will it react or not? And then if it reacts, then what kind of products will I get? Is it like, is it a reaction that happens automatically, or do we have to force it? Like all of this stuff. So there are rules around around reactions. Like when a reaction happens, it's not random. Okay. Or when there's a compound forming, It's not like mix and match. It's not random. It is governed by some rules. So those rules or laws, these are like two of the important laws that we'll be coming across, or that are really important in chemistry. The first is law of conservation of mass. Have you guys heard of law of conservation of mass before? Anything like this?
No, ma'am.
No, ma'am.
Ma'am, we've heard of law of conservation of momentum, but not law.
You
Yes,
heard
yes.
law of conservation of momentum, no? Like all of this follow the same pattern. What is the law of conservation of momentum?
Ma'am, is it when the like when there is an action, there is an opposite reaction? Is it that?
No, that is
No,
Newton's
no.
Ma'am,
That is
ma'am,
the
could you
third
repeat
law.
the question?
What is the law of conservation of momentum?
Oh, ma'am, that's the ma'am. Ma'am, 1 minute. Let me write it.
Huh. You can tell it as an equation also. You don't have to say it word for word. Like I just need to know, like, have you understood it? Say it in your own words.
Yes, ma'am. If there is no external force applied in a system, then the total momentum of the system will remain conserved. So that is a statement for conservation of.
That is the statement. So what do you
Yes, ma'am.
mean by the total momentum is of a system is conserved? मतलब अगर एक collision हुआ, like if one ball hits the other ball, how do you apply it? Like what do you understand by it?
Ma'am, so before ma'am, at rest and then after collision, the momentum should be equal.
Correct. So
Yes,
basically,
ma'am.
the
Ma'am, I just wanted to
initial
say the
momentum will be equal to the final momentum, right? Like before, whatever was the momentum, after also the total momentum should be the same.
Initial momentum.
Correct.
Equal to.
Now, when we talk about law of conservation of mass, instead of mass, it's going to be, sorry, instead of momentum, it's going to be mass. So the statement, the official statement is that it states that mass can neither be created nor be destroyed in a chemical reaction. So mass can neither be created nor be destroyed. Matlab, if I have something here, matter, like matter is, so in this context, matter and mass can be used interchangeably, because anything that's matter, like anything that has mass occupies space, definition में ही है. Like matter is anything that has mass. मतलब कुछ है इसमें, like it weighs something, it is something solid, right? Now if I have something, it cannot be created or destroyed. So I can't create mass out of nothing. Like I can't create a substance out of empty space. It cannot be destroyed. I can't destroy this. Like अगर मेरे like sanitizer का bottle है, अंदर sanitizer है, I can't make the sanitizer disappear. Like it doesn't go nowhere. That's what law of conservation of mass states. The application of it, what it means is that if you have, yes, Swayam, what's up?
You can make it disappear.
You can make it disappear in the sense I can make it disappear so that you don't see it, but it's not completely disappeared. If you do a chemical analysis
On your hand.
yeah, of the air around it and of my hand, you will still find wo sanitizer ke particles. Okay, so the application of law of conservation of mass is that whatever process happens, like in this case, agar kuch chemical reaction hai, that means the initial mass that you have before a chemical reaction took place will be equal to the final mass that you find after a chemical reaction has taken place. Okay, so if I'm doing any chemical reaction, like for example, if I take a closed box and if I weigh it, okay, closed box, like okay, so initially let's say I took some coal. Coal is black, so let's take some black. I took some coal pehle, and then I weighed it to be 100 grams. Now, after burning that coal, like let's say I apply like fire to it, the coal burns. So coal, after it burns, it turns into ash and then you have the smoke. Now I took a closed box because I don't want the smoke to escape and the ash obviously will remain over there itself. Then if I weigh the box again after burning the coal, then the weight will, or it should be 100 grams only. So the total mass before a reaction should be equal to the total mass after a reaction. That is law of conservation of mass. So it states that mass can neither be created nor be destroyed in a chemical reaction. Understood?
Yes, ma'am.
Yeah, okay. Yeah, Swayam.
So, ma'am, according to like what you have said, that so according to you, like the plasma, it doesn't have any volume, like no mass, right?
Plasma? Where did that come from?
So you like added fire, right, to coal. You burn the coal,
Correct.
right?
Yeah. So fire in the sense, yeah, like I did not add plasma to it. I just heated it up so that the coal can start burning. So I gave it energy. I gave it heat energy, basically.
Yeah.
Think of it that way. I increased the temperature. I gave it some heat energy so that it start burning. Okay. All right. But practically speaking, like if whenever something like your candle itself, when candle burns, you see that the amount of candle reduces, right? So where is all of that mass going? How is
Sublimation? Sorry. Like does it like it melts, right? So
that it melted also, like it will spread around, right? So that means
yeah,
that,
the liquid part.
yeah, like if I have this much candle, after it melts, like the amount of candle that I have should be the same. And what about the thread? Like after burning, what happens to the thread? Like the wick, candle wick?
It turns into ashes.
It turns into ashes. But is the thread heavier or is the ash heavier? Like are they in equal weight or is one heavier than the other?
I guess it should be equal according to this law of conservation of mass.
Try it. Okay. Acha, is any of you like is any of you like, do you have religious homes? Like have you seen, or you must have been to weddings, right? Shadi mein and all. Have you seen a bonfire being burned? Like have you ever
Yeah.
Yes, ma'am.
Yeah.
Yes, ma'am.
you know what wood looks like general, right? Before burning, like solid piece of wood. Now,
Yes, ma'am.
after the bonfire, have you observed the ashes that are left behind?
Yeah.
Yes, ma'am.
Now, can you compare the mass of the wood versus the ash?
No,
No, ma'am.
I don't think so because it
Ma'am, would
be
be
light.
Which one is lighter?
Ma'am, the
Ashes.
ashes are lighter.
Ashes are lighter, like they can fly away randomly, like a little wind and then the ashes start flying away, right? So
Yes.
then
Yeah.
where did that extra mass disappear off?
Ma'am, into the atmosphere, the flames, I guess.
In air.
Very nice. That is correct. So when wood is burning, ashes are not the only end product. You also have the smoke coming out of the flames, right? Smoke is nothing but gases. Like wood mein jo bhi carbon hai, that gets burnt, and when carbon is burnt, it turns into What gas
Ma'am,
when carbon is burnt?
carbon dioxide.
Carbon dioxide, absolutely. So this carbon dioxide is also a gas. So when you have a bonfire, so total mass of the wood that is burnt will be equal to whatever smoke ka mass, like whatever smoke is produced, uska mass, plus whatever ashes are remained, uska mass. Okay? Because smoke is also matter, air is matter, right? So this is also matter which has a certain quantity of mass, and ash is also a matter that has a certain quantity of mass. So that's how law of conservation of mass is held up. Matter can neither be created nor destroyed. Mainly, it just turns from one form to the other. So pehle wood tha, after the chemical reaction, it has turned into, like, some part of it is ash and some part of it has turned into gases. But it has not been destroyed. Okay, so that is what is conservation of mass. Next, you have law of constant proportions. So this law states that in a chemical substance, the elements are always present in a definite proportions by mass. Okay. All right. Carbon dioxide is something that we have come across, and we represent carbon dioxide by CO2. So what this law of constant proportions is saying is that in a chemical substance, so if we take that chemical substance as carbon dioxide, the elements are always present in, so what are the elements that you find in carbon dioxide?
Carbon and oxygen.
Yes, correct. So carbon dioxide is made of carbon and oxygen. And these elements, the carbon and oxygen, are always present in definite proportions by mass. So if you somehow are able to separate the carbon and oxygen from carbon dioxide, and then if you take their weight, no matter what carbon dioxide you take, like whether you take carbon dioxide from breathing out or whether from smoke or whether from atmosphere, whichever carbon dioxide you take, they will always have carbon and oxygen, and the ratio of carbon and oxygen will always, it's always in the ratio of 12:32, which is 3:8. Hamesha, if you compare the weight of carbon and oxygen individually as elements, they will always be present in this particular ratio. Agar ye ratio change hua na, like suppose you took some gas and then you found that it was made up of carbon and oxygen, but the ratio is not 3:8, then that gas is not carbon dioxide. Kyunki agar carbon dioxide hota, so you will always get the ratio of elements to be 3:8. So they're always present in definite proportions by mass. So that's why it's constant proportions, always present in the same proportions. Okay. Similarly, what is water made up of?
Hydrogen and oxygen.
H2O.
Correct, hydrogen and oxygen, and Swayam said, yeah, it is H2O. So always water may, if you compare the masses of hydrogen, like mass of hydrogen versus mass of oxygen, then the ratio is always going to be 1:8. Agar ye change hua na, if it happens to be 1:16 or something else, then it is not water anymore. It's a different compound. So that's what this law states. Law of constant proportions. If you take any chemical substance, whatever elements it's made up of, the elements are always present in definite proportions by mass. Okay? Clear?
Yes, ma'am.
Cool. Note these two statements down. And because these are laws, note down the statement as it is. Okay, not just bullet points. If you want, okay, I'll keep the text here and you can note down the explanation of it, an example if you want. But yeah, let me know once you're done noting these 2 points down. Yeah, note it down. I'll just get water. Okay, so theory based are like this you're already familiar with. They're direct questions. State the law of conversion नहीं, conservation of mass होना चाहिए. State the law of constant proportions. It's also okay. State the postulates of Dalton's atomic theory. Again, like you guys have written it down. It's a direct thing. Then differentiate between anion, cation, atoms, molecules. All of this thing. Practice questions. Okay. Molecular masses we are yet to discuss. What are polyatomic ions? Give examples. Okay, I've told you about polyatomic molecules, right? Okay, actually we'll discuss this in the next class because ions abhi tak discuss nahi kiya. Okay, fill in the blanks. In a chemical reaction, the sum of masses of the reactants and products remains unchanged. This is called Sujal. What is the answer? The others can send their answer over chat, but Sujal, this is your question.
Ma'am, 3.1.10, right?
Yeah.
Ma'am, just a second, I'll think it.
10A, right?
Yes.
Ma'am, it is law of conservation of mass.
Very nice. Sujal got it. Suhani and Ashka also sent it. Samriddhi also got it. Good stuff.
Ma'am, I thought only Sujal was supposed to answer.
He was supposed to answer, but you could send it on chat. Like if you know the answer, just send it on chat. Okay. Next, a group of atoms carrying a fixed charge on them is called Aryan. Aryan, your turn to answer. Others can send it on chat.
Oh, yes, ma'am. Ma'am, is it ions?
Ions is absolutely right. Atoms carrying charge is ions. Formula unit mass and formula, let's skip that. 11. Which of the following statements is not true about an atom? Atoms are not able to exist independently. Atoms are basic units from which molecules and ions are formed. Atoms are always neutral in nature. Atoms aggregate in large numbers to form the matter that we can see, feel, or touch. Samriddhi.
Ma'am, it's D.
D. Why do you think it's D?
Ma'am, I mean that we cannot directly feel the atoms. We can feel the matter, but I don't think we can feel the atoms directly or touch it. So,
but that's what D is saying, right? Like not individual atoms, but when they aggregate in large numbers. Aggregate in large numbers, matlab they collect together in large numbers to form the matter that we can see, feel, or touch. So if I have this, what is this made up of? This glass.
atoms.
So they're basically atoms in large numbers. So I can see the glass because all these atoms have come together and they're existing together. And I can feel it, I can touch it because they're there in large quantities. So I can't do that with a single atom or two atoms because it's like really tiny. But when they come together in large numbers, we can see them, we can feel them. Like that's what matter is, no? Matter is made up of atoms, they're coming together. Suhani has sent the right answer. Ashka, atoms are always neutral in nature. That is true. Because if they are not neutral, it becomes an ion. Then it's not called an atom anymore. If I'm calling something an atom, it's a neutral atom.
Okay, ma'am.
So the answer to this question, Samriddhi, not B also, because atoms are the basic units from which molecules are formed, no? So if atoms are chemically combined, they form molecules, right? So A is the right answer. Atoms are not able to exist independently. Not necessarily. Like a lot of times they're not able to exist independently, but a lot of times they do exist independently. Like the best example is your monoatomic elements, right? Helium, may the atom is existing independently.
Ma'am, but in the definition of atom, it was written that smallest particle of an element that cannot exist independently.
Like not necessarily, just like make that correction. So it is the smallest unit. The main thing is it retains all the chemical properties of the substance, and it may or may not exist independently. Like it depends on which atom it is and where it is existing and all that. Like if it is highly reactive, then yeah, it will want to form a compound. But there are cases where the atom is just existing on its own. Yeah, I can see like why you've gotten confused with this. Chemical symbols we have not. Again,
chemical symbols are so simple.
Yeah, you already learned. Samriddhi, have you done anything related to these concepts before? Chemical symbols or atomic mass, atomic number?
No.
No? Okay. Give the difference between cation and anion. Samriddhi, your turn. No, this was previously answered, right? Ashka, your turn. Difference between cation and anion?
Ma'am, cation is positively charged and anion is negatively charged.
Correct. Formula, unit, mass, also let's skip that. Give one word for the following. Swayam, positively charged ion, what do you call it?
Cation.
Yes. Suhani, group of atoms carrying a charge.
Ma'am, I can't see the question.
Oh,
Can you tell me the question number so I can see it in my book?
sure. 29B.
1 second, ma'am.
Level 1, 29, the question may, the B part.
A group of atoms carrying a charge, right?
Yes.
An ion?
Ion is right.
Ion.
Yeah.
And ion, it's different.
ION. And if you have to be specific, because it says group of atoms, you can call it a polyatomic ion. A polyatomic ion. All right. The majority of the chapter is just calculating the formula mass and the formula symbols related to that. Okay, level 2 first question. This is relevant for you guys. This is something that we studied today. So in a reaction, 5.3 grams of sodium carbonate reacted with 6 grams of ethanoic acid. So the products were 2.2 grams of carbon dioxide, 0.9 grams of water, and 8.2 grams of sodium ethanoate. Show that these observations are agreement with the law of conservation of mass. They've given the reaction also, so you don't have to worry about it. So sodium carbonate plus ethanoic acid, when these two react, the products that you get are sodium ethanoate plus carbon dioxide plus water. So this is the reaction. So based on this, how will you approach this question? How will you show that these observations are in agreement with the law of conservation of mass? Like, what do you need to?
Can you say that the total mass before the reaction was 11.3 grams, and after the reaction, the total mass was also 11.3 grams?
Absolutely. You need to prove that if you're getting the total mass before reaction equal to the total mass after reaction, then that proves that the law of conservation of mass is followed. Yeah, very nice. That's exactly what you need to do. So before reaction, mass of sodium carbonate plus mass of ethanoic acid, 5.3 plus 6. Yes, Ashka, you get 11.3 grams. Then after reaction, you have sodium ethanoate, you have 8.2 grams of that, plus carbon dioxide, 2.2, that makes 10.4, plus water, so you have 0.9. Add it, you get 11.3 grams. Awesome. So mass before reaction equal to mass after reaction. So it is followed. So yeah, this is the question I was talking about. Which postulate of Dalton's atomic theory is result of law of conservation of mass? Then out of those 6 postulates, you need to mention which one it is. Same thing, can explain the law of definite proportions. Okay, all these are related to the mole concept, which we'll do next class. There's one more question that of the type that I want you guys to see. Yeah, look at level 3, second question. So this would be the last question we discuss, then the class after this. So when 3 grams of carbon is burnt in 8 grams of oxygen, you get 11 grams of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 grams of carbon is burnt in 50 grams of oxygen? Oh no, I'm sorry. This is slightly complicated. Skip this. It's not a direct application. Okay. Anyway, revise this. This week you can focus on statistics, like practice that